Hi everybody. Okay, so today we're going to do a little video on exercise or lesson 1.4, least common multiple. Now we're going to be using the prime factorization of numbers to find the least common multiple of those numbers. Okay, now in the past, if you had two numbers, so let's take two numbers like 24 and 30, and you wanted to find out the least common multiple of 24 and 30. What you would have to do is you'd make a little table like this and you'd start writing down the multiples. So 24 times 1 is 24, 30 times 1 is 30, times 2, times 3, times 4, times 5, and so on and so on. And you'd have to keep doing this until eventually you found two numbers that were shared on either side of so these are the multiples of 24, these are the multiples of 30. You'd keep doing this until you finally found a number that was on both sides. That's the least common multiple. Okay, we're not going to do that anymore. We're going to learn a new way of doing this. And I'm going to show you how. We're going to use we're going to use prime factorization. So let's take a number. Let's take two numbers, actually. Let's take 18 and 24. Okay, so 18 and 24. And we're going to use the prime factorizations to find the least common multiple. So the first thing we need to do is we need to actually get the prime factorization. So this is 2 times 9, which is 3 times 3. So 18 is 2 times 3 times 3. 24 is going to be, we've done this one quite a bit, 8 times 3. Okay. Eventually you start to memorize these numbers. And 24 is equal to 2 times 2 times 2 times 3. Okay, now here's what we're going to do to find the least common multiple. We're actually going to take these prime factorizations and we're going to make the least common multiple, just like we did with the greatest common factor. So the first thing I'm going to do is I'm going to say that my least common multiple has to take one of the numbers. Okay, so let's take 18. It has to have all these factors. It has to have a 2, a 3, and a 3 in its prime factorization. I can't divide 18 out of any number unless it has these prime factors. Now I'm going to take a look at 24. And I hope that makes sense. That's kind of what we've been doing the last couple of lessons. So the next thing I'm going to do is I'm going to take a look at 24 and see what else I need. Well, let's see. I need 3 2s and a 3. I've got 1 3, so I'm good on 3s. I've got 1 2. I need to have at least 2 more. So I'm just going to go in here and add them. Simple as that. That's our least common multiple. 2 times 2 times 2 is 8, times 3 times 3. 3 times 3 is 9, so 8 times 9. This number is 72. And that's the least common multiple of 18 and 24. Okay, now I took a long time doing that because I just described every step. But once you get a hang of this, this is so much faster than doing the old chart way. Like let's just go ahead and do the chart way to refresh your memory on how to do this. So I would take 18, 24. How do you like my graph? Pretty sweet, right? Okay, so let's see, 18, 36, 18 times 3 is going to be 54. If you didn't know that, you'd have to go to your calculator. Plus 18, we've got 72. We'll go up to 90 or so. Here we've got 24. We've got 48. 24 times 3 is going to give us that 72. And there we go. Well, that's a kind of a bad example because that didn't take very long. But this way over here works for every type of number. Big numbers, small numbers, any number you can imagine. This way works for all numbers. Okay, that's why we like it. So let's try another example. Let's do some more complicated numbers. Let's find the least common multiple of 144 and what do we want to do? 40. Okay. Now these are huge numbers. You would not want to have to sit down and do this kind of math. You wouldn't want to have to write a column out here and write down I mean, seriously, you want to do multiples of 144? 144, 288, that's it. I'm done. I don't want to do this anymore. Okay, so you'd have to do that a bunch to actually solve this one. Now, let me show you how easy it is with the prime factorization. So 144, and eventually you start memorizing things, okay? I know this is 16 times 9. I know 16 is 2 to the 4th, and 9 is 3 squared, okay? That's all I need to do. This is 144. 40 is 8 times 5. Well, 8, by now, we've done that quite a few times. 8 is 2 to the 3rd, and 8 times 5, 5's prime. Okay. So all I did was what we did before, but I did it in a slightly different way using the exponential notation. Now I'm going to go ahead and create my least common multiple. Let's see. I need 2's, 3's, and 5's. I'll just go ahead and write them down. How many 2's do I need? Well, this one needs 4 2's, this one needs 3 2's. So if I put in 4, we're good. Okay. I need at least 2 3's. And I need 1 5. There we go. There's my least common multiple. 16 times 9 times 5. I don't know what that is. Let's find out. 16 times 9 times 5. 720. Okay? And just like that, we've got our least common multiple for 2 huge numbers. Okay? This would take forever doing the chart way. Now, let me break that down for you a little bit. I'm going to go ahead. I kind of jumped some steps here because I used exponential notation. What you might do is this. You probably count them out. Oops. And 40 is equal to 1, 2, 3 of those 2's times 5. Let's go ahead and do this again. Okay, so let's go back and let's take this a little bit slower. Now I know my least common multiple has to be divisible by 144. That's the definition of a multiple. If it's a multiple of 144, it's got to be divisible by 144. So I'm just going to start by writing out all the numbers that go into 144. So 2 times 2 times 2 times 2 times 3 times 3. The next step is to take a look at 40 and see what's missing. For 40, I need to have at least 3 2's. That's my 8. They're right there. I don't need to add any 2's to my least common multiple. The one thing that's missing is this 5. And there you go. Simple as that, we have our least common multiple. Okay? Really not too much to it. All right, let's go ahead and do one application problem and then call this video good. Okay, so we have a track. That's a track. We're going to call that a track, okay? You start here, you run around the track, you end here. It's nice, it's a gentle curve. There's no straightaways, it's all curve, okay? Okay, and we have 2 runners, okay? We've got Natalie and we've got Monica, okay? Now, Natalie can run a lap on this track in, let's say, 30 seconds. 30 seconds. Monica can run, Monica's pretty quick. Let's just be fair, okay? So he can run a lap in 20 seconds. He's a quick dude, okay? Now, the question states, if they both start here at the same time, when is the next time they will meet at the starting line? Okay? They're just going to start running laps and keep running laps, running for days, okay? And I want to know when it is that they will both meet at the starting line again. Okay, so here's what I'm going to do. Let's see, how can I organize this a little better? Let's take this, scrunch it up a little bit, move it over here, and let's make a table over here. Well, let's see. Natalie, Monica. Okay, at time 0, so before we start running, they're both at the starting line. When will Natalie be at the starting line again? Well, it takes her 30 seconds to run a lap, so she'll be there at 30 seconds. She'll be there after 60 seconds. She'll be there after 90 seconds, after 120 seconds, and so on and so forth. When will Monica be here? Well, his first lap takes him 20 seconds, and then 20 more seconds, and then 20 more seconds. and then 20 more seconds, and so on and so on. So the question is, when will they both be at the starting line at the same time? Well, you can see that this is a least common multiple problem. Okay. Monica and Natalie will be at the starting line at the least common multiple of these two numbers here. So every 60 seconds, they will meet here. Now, I chose very simple numbers, and we didn't have to use the prime factorization. We made a chart, but I'm just doing that to show you how the problem is set up. You could actually just go straight here and say 2 times 3 times 5. Natalie's is 2 times 2 times 5. I need 2 2s, a 3, and a 5. That's 60. 4 times 15 is 60. So we would say every 60 seconds. But I just want to break this down and show you how this problem is a least common multiple problem. You can do the chart way if you want, but I think that the prime factorization way that we just learned is much faster. Okay, that's a mouthful. I hope that this helped, and good luck on your homework. If you have any questions, write down your problems that you're having trouble with and let me know. All right, bye.